G'day, I'm Brett Dutoy. I'm the founder and owner of Crisis Fire Doors Pty Limited. Today's video is an instructional video about how to install our single fire door assembly in a steel frame. The particular frame we're looking at today is made from 1.6 mild steel. This door assembly is our Fireman Class A steel frame assembly, providing 60 minutes fire resistance to anywhere in the building. What's relevant about this fire door and our fire doors in particular is that we test on both sides. What's important about our fire doors is that we test on the weakest side of the fire door, which is on the open in face. To our knowledge, we're the only manufacturer in Africa that has this test completed and passed. And today you'll see how we go about installing this particular fire door. We make these Class A fire doors both in a steel frame, and we also do them in a timber frame. And both of those are tested, and our test reports are provided to our customers. The first thing to note about the installation is that you require a minimal amount of power tools. It's essentially a hammer drill, a cordless drill driver, an impact wrench, possibly a screwdriver, a level, a tape measure, and then your consumables that go along with doing the installation. Prior to manufacturing of the door, we issue our shop drawings to our clients. Those shop drawings are based on the dimensions given to us. The dimensions we ask for is the clear opening of the width of the opening and the height of the opening. We then provide shop drawings that are 10 millimeters narrower left to right, 10 millimeters shorter on the top, the door assembly to be placed into the opening with space and wiggle room to play with. On site, when the installation takes place, you'll see that we confirm the measurement of the opening, the width at the top, in the middle, and at the bottom, on the hinge edge and on the lock edge to confirm that we are within the tolerance. We then position the door assembly into the opening. At this stage, it's a loose fit. We then wriggle the door into the placement of the reveal. In this instance, the door assembly is to be centered on the reveal and not flush to one side. So we center it in the reveal and we place a shim or a wedge at the top of the frame on the hinge edge first. Then the second part is we place a shim or a wedge on the lock side of the frame at the very top. That just basically secures the frame in place. At this stage, you can literally open and close the door because it's secured. The next thing we do is we plumb the level at the head to ensure that the head is not at an angle. So we get the head level first, and then we plumb the edge of the hinge edge to make sure that the hinge edge is not proud or is not sharp. So it's dead center and it is truly plumb and level at the head and plumb at the stile. Once that's done, we put fastener number 1 in, which is at the top on the hinge edge. We then come across to the opposite side. When we come to the opposite side, the lock edge, we ensure that, again, we are centralized in the reveal. The frame is centralized in the reveal. Once that's done, we put in fastener number 2. Once fastener number 2 is completed, we come back to the hinge edge of the door, and again, we check the plumb and the level of the frame, and we put in fastener number 3, which is at the bottom. The other important thing to note about the architecture and the engineering of our doors is that where you have the bolt-on hole coming through the frame, you can access that with a number 16 socket quite easily if you're going to use thread bars, right up to a number 17 socket. It's a 26 mil hole, so a socket easily fits in there. In this instance, we're using frame anchors, which are 10 mils thick and 115 mils deep, designed specifically for frames. Where it goes through the access hole, there's a brace at the back of the frame. The brace doesn't have a hole on it, it has a slot on it. That allows for any lateral movement of the frame at the bottom, and you'll notice that later when we start plumbing the lock edge. So with that said, we then place fastener number 3 into the wall and we tighten it. Then we come back to the lock edge. Now we need to focus on fastener number 4 at the bottom. This is the final opportunity that you have to adjust the gap where the door strikes against the frame rebate. So the door opens that way, it then closes on the rebate. The idea is that the gap at the top, if the top of the door strikes the rebate first and the bottom of the door, it must also strike the rebate. In this video, we've demonstrated exactly where the problem exists. We made about a 25 to 30 mil gap at the bottom. The only way to rectify that is by moving the bottom of the frame. So you move the bottom of the frame to a position where the door is now striking the rebate all the way up, which now is how a fire door should be installed. At that point, we secure the bottom of the frame with wedges or with shims. At this point, you're almost complete. Next, what we'll do is we'll come along to fastener number 5, which is again on the hinge edge. We'll tighten fastener number 5 because we've already plumbed and leveled that style of the frame. We don't need to make any adjustments at all. And once fastener number 5 is in, we'll come across and we'll start paying attention to fastener number 6 and also fastener number 4 at the bottom. We'll close the door and we'll inspect the gaps. The gap around the fire door should be 3 millimeters on the hinge edge, 3 millimeters across the top, and 3 millimeters all the way down the lock edge. In the video, you'll notice intentionally, we have a 3 mil gap at the top, and you'll see that the gap is opening all the way down to the bottom to the extent of about 7 or 8 millimeters. That's not sufficient. The way that we close that gap is now we drive wedges in behind the frame at the bottom. That now closes the gap. Once we've got that gap to 3 millimeters, we then tighten that fastener without drawing the frame further into the space between the wall and the frame itself. We then move up the frame, and now we can see in the video, there's a bigger gap in the center of the door. We then drive wedges in again, which ultimately pushes the frame towards the door and closes that gap to 3 millimeters. Once those wedges are in place, we know we can tighten fastener number 6. We tighten fastener number 6 and we observe the gaps. We now have 3 millimeters up the hinge, 3 millimeters at the head, and 3 millimeters all the way down the lock. At this stage, we are now almost complete with the installation. The next thing that we do is we come to the backfilling of the frame. Historically, contractors have always backfilled frames using concrete. It has its pros and its cons. On the downside, what it tends to do, in many instances, we've noticed that as the concrete or the dargo starts to cure, in some cases it expands, and so it pushes the frame closed, and you get the door starts to bind on the frame, and it doesn't open and close properly. So what ends up happening is they start taking the doors off, they start planing the doors, which is totally unnecessary because that door is a pre-hung assembly in our factory. It's squared on CNC machines. We laser cut all of our frames. We CNC cut all of our doors. So everything is precision to 0.01 of a millimeter. There's no need to make adjustments on site. The only reason that adjustment will be made is because of the quality of the installer. The fire door is only as good as the installation. That's why it's important to follow our technique, which is designed specifically around that to alleviate problems and to make it faster. You'll notice that the entire installation from the moment we positioned the door assembly in the opening took 45 minutes till we were complete. That's how long it takes 2 guys to install a fire door. So now that we have completed the fasteners and we have our consistent gap all around the frame, it's now to backfill with foam. Expanding foam expands dramatically. It can end up all over the floors, all over the walls, on the floor. And the important thing to note when that happens is not to try and wipe the foam off whilst it's wet. Let it dry, because once it's dry, you can literally peel it off and you'll be left with hardly anything left. So very important to note. So prior to backfilling the frame, we use duct tape all the way up the outside edge, in this case, the passage face of the door, because we're working on the room face. We duct tape all the way around, all the seams along the top, the junction between the frame and the wall all the way. That's to prevent the foam from extruding too far out into the passage and thereby not backfilling the frame. So therefore we tape the entire system. Then we come onto the inside and we start backfilling the frame at the top. Usually there should be about a 10 millimeter gap. If you've got anything over 10 millimeters, then you need to consult with a fire engineer of how you should be backfilling those holes. So here we have a 10 millimeter gap. We backfill that gap with the PU foam, and we then put duct tape over that again to stop expansion coming towards us and to rather encourage expansion to fill up the cavity inside the frame. Then we'll come to either the hinge edge or the lock edge. Really doesn't matter at this stage. We prefer to do the hinge edge first. We'll start at the bottom and we'll start backfilling all the way up the frame As we go up the frame, we'll again apply the duct tape all the way to the top, again encouraging the spread of the foam inside the steel frame cavity rather than outward. Again, we'll repeat the same thing on the lock edge, starting at the bottom and working our way up, all the way to the top, and again, duct taping it in. If you find, you will see in the video that there's broken plaster in many instances, so one stripe of duct tape is insufficient. So we end up putting 3 stripes or 4 stripes. Doesn't really matter, it's going to come off later. It serves a purpose while that foam is curing. In our climate, in South Africa, you'll generally find that after about 45 minutes to an hour, that foam is pretty much cured. But we like to wait 24 hours before we remove the tape. So once we've now backfilled the frame all the way around between the plaster, or between the cavity of the reveal and the frame, we then come to the opposing face in the passage where our fastening holes are. We went at fastener number 1, fastener number 2, fastener number 3, fastener number 4, fastener number 5, and fastener number 6. We start pumping foam through that access hole. As we pump foam through the access hole, pointing down, foam starts to rise, taking up any space that may be left, and we then duct tape the hole closed. We come across to fastener number 6, we do the same thing, we duct tape the hole closed, and so we move up the frame. And then you'll notice that all the holes have now been duct tape closed. That now completes the installation, and the next step would be for the contractor to undertake. You'll also notice that the brace of the frame is still in position. That's to ensure that the frame remains square at all times while installation is taking place. The following day, the contractor will come along. He will remove all of the duct tape, dispose of it. He will then generally scrape out some of the foam down to about 15 millimeters deep, or deeper than his current brickwork is or plaster work is, on both faces. He'll then plaster up to the plaster band on the frame and penetrate into the 10 or 15 mil cavity that he's created between the reveal and the door frame, all the way around on both faces. That again ensures that there'll be no flame creep coming through behind the frame in any position. Your most common point of failure on a fire door is on the lock side of the door at the top corner, away from the hinges. And the reason is because the hinges keep the door in position. And as a fire takes place, the hot air rises, cold air rushes in to take the space of the hot air rising, puts pressure on the door. So if the fire's inside this room and the door's opening in, the air will rise, the fire will try and, the cold air will rush towards the fire, further fueling it, and we find that it's the top corner that moves away because there's nothing keeping that corner in place, like a hinge on that side. That's why we have our patented design firebolt. And what happens with the firebolt is that at 140 degrees, the firebolt will activate and it'll fire a pin into the top of the frame and a pin into the side of the frame, depending on which type of fire door it is. That then stops the fire door from going into the fire. And this is how we achieve our Class A and our Class E fire rating in timber frames. In fact, our Class E door failed at 64 minutes. It's a 30-minute fire door. It failed at 64 minutes, and it failed at the access controlled lock. Our Class A 60-minute door failed at 68 minutes, also at the access control lock. Even with a door viewer or peephole in place, also with a concealed drop seal at the bottom, there was no failure at any of those points. It always tends to be at the lock and definitely not at the corner above the lock. And that's due to the way that we engineer our fire doors and due to the research and development we've done over the last 16 years on our products. So we're confident to supply these products into the market and confident that this will save lives and it will save you money and it will make your insurers very comfortable to provide cover to your buildings.